Some graduates enter the workforce and immediately begin a rapid climb. Others remain stuck in the same position for years, despite having identical credentials. This divergence is driven by 5 specific skills that academic institutions almost universally ignore. Most freshers experience a sharp disorientation the moment they step off the campus and onto a chaotic production floor. The transition from a theoretical classroom to a live industrial environment is rarely seamless. A university's primary goal is to make you hireable. An industry's primary demand is for you to create tangible value. That gap is where most careers stall before they even begin. Stagnation often results from applying classroom logic to a floor that operates on a different set of rules focused on industrial output rather than academic rubrics. The true path to industrial competence always starts with the most basic element of engineering execution: the drawing. In college, drawings are pristine. On a live floor, they are cluttered with revision marks, tolerance callouts, and surface finish symbols. Mastery means looking past raw dimensions to identify the variables that dictate quality. You must know which flags lead to rejection. Once you can read the floor, you have to understand the why behind the work. Accepting a process because that is what you were told is the point where professional growth stops. The fastest-growing professionals ask why to map the logic of the system. Once you understand the mechanics of a process, you can begin to improve it rather than just following it. In a live production environment, downtime is a financial penalty. Communication must be clear enough to cut through the noise of the machinery. When a machine stops, a beginner might report that it isn't working. A professional reports that the spindle overload alarm is triggering during rough machining. Using the exact technical language of the shop floor is one of the fastest ways to earn the trust of the veteran staff who actually run the plant. Trust leads to more responsibility, which introduces a new pressure: balancing high-speed execution with zero-defect accuracy. Academic labs allow you to spend 10 minutes on a single measurement. On the job, the targets are live and the customers are waiting. You don't have the luxury of slow precision. This matrix shows the shift from the academic quadrant to professional excellence. To become a highly trusted professional, you have to move into the space where high speed meets high accuracy. But even with high accuracy, occasional failures happen. Exactly how you handle a part rejection defines your career trajectory. An average employee reports the symptom: the dimension is out of tolerance. A future leader interrogates the failure to find the root cause. This diagram maps the network of variables behind a single failure. To solve it, you have to look at tool wear, fixture stability, programming errors, and material variation. Most industrial workforces have plenty of people who can identify a problem. They have very few who can actually provide the solution. Machines are designed to follow instructions. Tracing an error to its root cause is a uniquely human capability, and it is one of the most effective ways to prove you are ready for a leadership role. These aren't just concepts for the future. They are actions you can take in your first week on the job. Use this as your career checklist. Read the story behind the drawing. Question the logic of the process. Speak the technical language. Balance speed with accuracy, and troubleshoot the root cause. Imagine a supervisor hands you a complex drawing with a tight tolerance callout. Instead of asking what the number means, you ask why the tolerance is so tight and how it affects the parts being made in the next department. That question signals that you are an asset to the entire system. To start, pick one process today and ask why 3 times. Practice describing a problem in a single technical sentence, and never report a failure until you've attempted to trace it to its source. A university degree proves you can absorb information. These 5 skills prove you can apply it in a high-pressure environment. The degree earns you the seat, but these 5 skills determine how fast you move once you're on the floor. Tell us in the comments, what was the biggest reality shock of your first job? Subscribe for more deep dives into industrial mastery.